with like np dot zeros. You can create a zeros arrays. So you just need to provide your shape, maybe 5,5. So you create
Uh-huh.
the zeros arrays. You understand that? Or 5,1.
Yeah.
We only have two of that,
Oh,
zeros and ones.
okay.
So you can't say that dot tens or six. We only have two tens, zeros and ones, and we also have np dot zeros
Okay.
and np dot ones. Np dot ones like this. So this np dot ones, we have this. So for example, now if I want to populate this particular area, I want to everything to be 10. I just have to multiply it by 10. 10 times everything.
Okay.
So we're going to have everything to be 10. That is what I did here. np dot ones 4,2, then multiply everything by 100. Do you get that?
Okay. Yes. Okay.
So you can reshape, but what you are trying to reshape must be reasonable. Do you understand that it must flow? You cannot say that you want to reshape an original array that is maybe 20,1. You now want to reshape it to maybe to something that does not suit. It's not suitable. So let's proceed. And also there's also flattening. You can also flatten your array. So in this particular array, we have our x2. Then here we shape x2. So I can flatten this x2. There is x2 dot array dot flatten keyword. So this is an array. It's going to take an array. You can flatten it. Flatten means that normally it's in 4/2, just like you want to flatten it. So it will not just have just 8 items. So that is the meaning of flatten. Do you understand that? So it's flatten. This is what it means by flatten an array. So we have an array.
So
Hello?
yes, I can hear you now.
Yeah, we
Hello?
can hear you now.
Hello?
Okay. So let's continue.
Okay.
So it means that flatten means that you want to flatten a particular array. Do you understand that? There's a particular original.
So we didn't get the flattened part very well. Maybe the internet something.
Okay.
Like what is flattening about?
Okay. So look at this particular array. We have how many items in this array? 8 items,
Flattening.
abi?
Yes.
But it's in shape of 4,2. Do you get that?
2.
Is in shape of
Oh.
4,2. That is 4 rows and 2 columns. So flattening means that you want to arrange it, make sure that they have just one particular rows. They will not have one rows. Just combine all the data together, represent them into just like you flatten a particular shape. So it's going to flatten it into like all these rows are now going to be 1. All this one will be 0. This is the first item here, and this next 4 items. Do you understand that?
Okay.
So that is what it means by flattening it. Like it's in 4,2, but flattening is going to give you just one rows. All the items will be combined together in form of just one rows. Do you understand that?
Okay. Okay.
Yeah.
Let me make another example. Let's look at this particular example, the first array, like x1, okay, x2 array, x2 array. Look at this. So you have this, if you flatten it like this, dot flatten. So you can see what it's going to give us. So you just arrange everything in a single row. Everything is being arranged in a single row. Do you get that?
Yes.
It's very, very straightforward now.
Yes.
Okay, so that is that about. And there's this part, you can also transpose a particular array because this array it operates like a form of a matrices. You understand? All these matrix operations can be performed on it, like dot product, cross product. For example, looking at this, look at this particular array. Okay, there's really a lot of functions. You just have to once you start using it, regularly you'll be familiar with functions. Look at this s2 dot array. Look at this. So I can transpose it. Dot T is going to transpose the array. Dot T
Mm.
transpose means that rows will be columns. Column will be rows. Do you understand that? Let me try to display the original arrays first. Let's say x2 array. We run this particular line of code. So then we now say that dot transpose rows is dot T. You see that the rows is now columns here. The columns has been turned to rows. Like this one that is in this particular row, 10, 50, 10, which is in the first column. There's now in the first rows, 10, 50, 10. Do you understand that? That's the
Yes.
meaning of dot T.
Okay.
Do you get that? So you can transpose a particular array. You can perform dot product, like perform dot product. You can use, and there's this other function. I think you also have np dot diag, which is going to give you the diagonal of the array, s2 dot array. So it's going to give us the diagonal of this array, which is 10, 10, 30. Do you understand that?
Mm. Yes.
So let me try to put comments here. np.t is going to what transpose the array. Then we have np dot diagonal
The
that is going to give us the diagonal of this array. Diagonal of the array. So then we also have array dot flatten. So if you have a particular array, so we use dot flatten, is going to turn it into a single row array. It's going to flatten it into a single row array. Do you get that? Do you get that? So if you want to find,
Yes, yes.
let's say that you want to find the sum of the diagonal. So how are we going to find the sum of the diagonal? So we have a particular array like this x2 array. We want to find the sum of the diagonal, which is 10, 10, 30. How are we going to find the sum of diagonal? Have I mentioned np.sum? np.sum is for sum. I haven't mentioned, did I mention it here? So
No.
we have, so for you to calculate the sum, it's just simply np.sum. So it's going to calculate the sum. Do you get that? So you can also calculate sum along a particular axis, like we did here. You understand? So you can calculate sum along an axis, like np.sum x2 array. So it's going to give us the sum of everything. While np.sum for a particular axis, axis is equal to 0, 0, which is the first axis. You can calculate for the first axis. Then you can also calculate for the second axis using the same np.sum. So axis 1. So do you get that?
Okay.
So it's very, very clear, very, very interesting. So you can do that. So my question now is that if you want to find this particular sum, the sum of the diagonal, how will I find the sum of the diagonal?
It will be np dot diag sum.
np.sum.
np dot
sum.
in bracket diag. No.
And it's just np.sum and np.diag.
Okay. np dot diag. Okay.
Then you first look for
Then
the diagonal, then you calculate the sum.
x2 array.
You understand that?
Okay.
So it's going to calculate which is 10 plus 10 plus 30. Do you get that? Then
Yes.
this particular arrays also support array multiplications. I've mentioned that several times. For example, if you have a particular array, np.array, maybe 5, 6, 4, you can multiply it by np.array, 10, 4, 2. So you can multiply these two together. So it's going to multiply individual items. 5 times 10, 50, 3 times 3, 9, 4 times 4, 16. Do you get that?
Mhm.
So then also, if you can perform matrix multiplications, like if you have this, let's say that x equal to x1, okay, let me say a equal to this and b equal to, you know, matrix multiplications very well.
Yes.
So you can see that if I say a dot transpose of a, okay, a does not even have a particular shape, does not have a shape, or the shape is just, let me say dot shape. So it does not have a shape. So you can try to reshape it. Let's try to reshape this into
Okay.
a equal to np dot reshape.
Sure.
So a comma new shape is, I want it to be 1, 3, and the next one to be, which is b, to also be 1, 3. So if you have this particular arrays like a is 1, 3 and b is also 1, 3. So if you multiply this, you have what we had before, because there's another one to use, maybe transpose. You can see that these are matrix multiplications. It's a dot t, that is, if I transpose the first item and I multiply it like this. If I transpose the first item, then I multiply it by b. So what will I have? Something like that. That is what I mean by matrix multiplication. Or there's also n a dot dot. I think there is a dot dot of b. So this, like, you are performing a dot product. Okay, so let's say b dot c. So it means that you are performing a dot product between a and b. So these are for mathematical computations. You understand? So in case you want to use for some other mathematical computations. Do you understand that?
Okay.
So you might not need to go far into this. For example, if you want to calculate, use matrices calculations, do a lot of matrices calculation, you can do something like this. So that is that about that. So you have the time out now. So we'll come back now, then I'll give you a practical examples. Do you understand
Okay.
that?
So if you want to do like variance now, so we just need to use VAR,
I think it's
just like the way we did standard deviation.
I think it's VAR, but I'm not sure. Let me see. Epic.var S2 array. Okay, there's this variance. Yeah, compute is variance. So it's the same thing. It's variance.
Okay.
Variance is epic.var.
Okay.
Okay.
Our problem is